Welcome back to this course. Today we are going to do the lecture 5 and the basics of the Matlab. So, let us start with the Matlab. So, this is the Matlab. So, in the previous class we have started with that how we can define the functions, anonymous function and inline function. So, in the last class we have just started the function. So, today I will give you the definition that another command. So, this is we are going to do today that how to find root of a function of a maybe equation. Like I have a function. So, in the last class suppose I have defined the function f that is equal to inline function I have just defined maybe x square multiply by sin x. So, this is the function I have defined in the last class, the x square into the sin x, and then we have discussed that I can define this, find the value of this function at pi or maybe some another value. Now, suppose I take a command that is called f0. So, this is the command f0. So, this what is the f0? F0 is single variable non-linear zero finding. So, it will gives you that suppose I have a function and you want to find the zeros of that function, maybe roots of that function. So, this command gives you, so that is the notation of this command, that f0 and whatever the function we are defining, and x0 is it gives you, it will find out the root near close to this value x0. So, suppose the same function I want to do and I want to find out what is my root. So, I just write it x0 that is equal to f0 and my function f just now I have defined, and I want to find the 0 value of this function near 0. So, it gives you the value of 0, or maybe I can define this one. So, that is again the value of 0. So, it means the function capital F we have defined. So, this function has the value 0 as the root of this function. Maybe I can define another function. So, this is suppose I defined another function. In this one I will change to plus 1. So, that is another function I have defined. Now, I want to find its zeros. So, this is the 0 I have defined. So, now I am defining the zeros, finding the zeros of this function near x equal to 1, and it gives you the value minus 1.068. Similarly, I can define the value near 0. So, that is another same value I am getting. It means that the roots of this function close to 0 or 1 is the same as minus this one, or maybe I can define minus 1. So, it gives the minus 1. I can define a polynomial like, so I define just another function, I just define the function, another function capital F, and now in this case I define a polynomial cube plus 2 star 2 dot star into x square minus 4 star x plus 1. So, this is the function I am just defined. This is the polynomial we have defined, x cube plus 2x square minus 4x plus 1. Now, I want to find the value of this function at maybe 0, just check. So, its value is coming 1. Now, I want to find the zeros of this function, a polynomial. So, in this case suppose I want to find the value of the polynomial near 0. So, that is the x value, that is 0.3. So, if I define the value of the function at 0.3 or maybe answer, so that is the value 0. It means that x0 is the root of this function. So, by the help of this F0 command, we can just find the root of the given function, whatever the function we have, near the point, because here we have to give the initial approximation that in which vicinity we want to find the root. So, this way we can find the root. So, now to going further, so this is all about the function. Now we can define that how to define the script file. So, let us start with this one. So, in this case I will go to this new, and here it will give you that what you want to find out. So, I want to write a script file here. So, this is the script file. So, in this the script file, whatever the command I have typed on the command windows, the same thing I can do in the script, and I can run the whole commands together after writing in this script file. So, let us start with this script file. So, this is my first M file. So, in this case, and I always start with CLC and clear all. So, CLC means whatever the written on the screen, when I will run this code, it will clear all the commands on the command window, and it will clear all the variables whatever is available in the workspace. Now, I can define, maybe I can define a variable t. So, I just define this linspace, and from maybe I just define from 0 to 2 pi with 100 number of default points. So, that is my value of t. Now, I define the another function, the x of t. So, x of t I just I can define by the way that, so I just define x is equal to maybe t star, maybe I can define cos of 3 star pi star t. So, this is the function I am just defining. So, that is my x. Now, I define the y is equal to maybe the same way. So, t star sine, this is the vector I have to define, sine 3 star pi star t. So, that is my y, and then I define the z is equal to maybe just I define t, and that is it. Okay. And now, suppose I want to plot this one. So, I will write EJ plot. So, EJ plot, so in this case I have 3 variables. So, it is a 3D plot. So, I will write EJ 3, and then I will define x, y and z, this one. Okay. So, this is I just in the code I can always write the commands, which is just for my understanding that this is for 3D plot. So, 3D plot, this is the function we have defined, the parametric function in the 3D, that is a function of t, x, y, z, and then I want to plot this one. So, now suppose I want to run this one, but before this one I have to save this function. So, we write it as save as, and I can define here the first dot m. So, this is the command. You can change the directory also, maybe I can define here nptel code and then saving this one. Now, I can run this code. So, it will ask you change the folder, and now it gives you the answer. So, that is the EJ plot we have just defined, and that is the spiral, you know that this shows you a spiral. So, that gives you the plot of the spiral function we have just defined here, and this is the value of the function. So, x is equal to t cos 3 pi t, y is equal to t sin 3 pi t, and z is equal to t. So, instead of writing each command again separately and then finding the final command, that is a plotting, but instead of that one, the all commands we can write in the script file, and then we can run the script file together, and then we can have this one in the single code. So, that is the script file. Similarly, I can define another function. So, I can change this function. Instead of this, maybe I can now I can define here I can maybe define f plot. So, f plot is what? It gives you the plot of the one function only. So, in this case maybe I can define f plot of x, just x. So, that gives you the f plot. So, f plot gives you that this is the error. Okay. So, I can define, so f plot is this one, and this is the t function I have defined. Now, I can function x is equal to, now I define the function x is equal to maybe sin t. So, this is a function I have defined. Now, I can plot this function, this is t and this is maybe x, and in this case, so now I can plot and I can run this code. So, that is the plot I got. So, instead of writing that function in the inline form or in the function form, I can define this as a vector form. So, this x is equal to sin t, and I can plot this function for this one. Maybe I can define the another thing. I define another function, maybe y is equal to exponential e to the power minus t. So, this is the function I am just defining, and t is from 0 to 2 pi. Now, what I do is that I use semi-log. So, semi-log is, then I will write semi-log x. So, it gives you t x or t y, and then I can define grid. So, that is the function we have just defined. So, semi-log x means it gives you the log at the x axis and value of the function at the y axis. So, this is the log x. So, it is a 10 to the power 1, 10 to the power 0, 10 to the power minus 1, 10 to the power minus 2. So, it gives you the x axis as a log value and the y axis as just the linear value, the real numbers whatever. Maybe I can define the another function from here. So, I define just x is equal to this. So, let us define another function xx. So, the xx I just defined exponential of t, and then I define another function yy is equal to maybe 100. I just define 100 plus exponential 3 star t. So, this function I am defining. So, you can see that here the function is exponential and the here yy is another function 100 plus exponential value. Now, I want to plot this function. So, if I define the plot xx and yy. So, this one I just put the sign here. Now, this is the plot we got. So, from here you can see that x, the value of the x is 100, 200, 300 up to 500, and the value of y is also very large. it is going give you the value 2 into 10 raised to the power 7. So, basically if we want to, if we are dealing with the large values on the x axis and on the y axis, so instead of plotting the function I can write down here log plot. So, this is a log plot. So, now I can define x, y, and here I can just command put the, so that is the same function we are plotting here, but now it is giving you the log. So, it means that the x axis is giving you the log value of that and y axis also the log value of that. So, in this way it is very easy to understand that okay, this is the function. So, whenever you are dealing with a large value, it is always better to plot in the log form. So, all these things you can do in the same file, or maybe suppose I want to have all these plots together. So, in this case what I will do, I will write figure 1. So, this will give the figure 1, and then I can define figure 2 here, and this is another plot. I am just figure 3, and this is the another plot is figure 4. Now I can run this one. So, you can see that it gives you all the plots together. So, that is plot 4, plot 3, plot 2 and plot 1. So, all the plot comes together because I have defined the function figure, each figure for each plot. Okay. So, if I want to close this one all together, so I will write just here, I will write close all. So, it will close all the graphs, whatever the plots we have made. So, by this way, so this script file is basically, now you understand that this script file is used whenever we want to compile large number of commands together. So, that is a script file. Now, the same way I can define another file. So, let us define another file new, and that is the function file. So, that is the function file I can define. So, this is, I will start with the function, and this is the output I am going to define, and this is the input we are going to define, and that is the name of the function. So, I will just write here, maybe suppose I define just the value y, and here I am defining the input, I am giving maybe x, and this function I am defining is sq square function. So, just I am defining this. So, in this case what I am doing, if you pass the value of x to me, then this function will give you the square of this value. So, I just write full name or maybe the small name square, and that is the body of the function. So, here I can define my function y is equal to x square, and then it will return the value. The only condition is that if I want to save this function square, so I have to first save this function. So, save as. So, the name of the file .m and the name of the function should be same. So, in this case it automatically coming squ.m, and I will save this one. Now, suppose I want to use this function later on. Now, suppose I want to run this code. So, what will happen? So, it gives you the square, not enough input argument, because you know that in that case we have to pass the value. So, if I write squ and is equal to 2. So, let us see. So, it gives the value answer 4. So, now in this case I am calling the function square from here, giving the value 2 here, and then it is giving the value 4. What will happen if I pass maybe, so in this case my x is 100, okay, So, now what I will do, I will just pass the x here. Now see, it is giving the square of that one, or maybe I can clear all CLC. Okay. Now I can pass sqn and 2. So, I have to first go to that directory where the function is defined. So, let us see what are the files there. So, this is SQU. So, I will write SQU, because you have to be in the same directory where the function file is saved. So, this is the function file saved and I am there. So, this is my value of the function. Now, suppose x I defined maybe 0, 1, 2. So, this is the value of the function. Now, I want to do the square of all this together. So, that gives you the value of the function. Maybe I can define the same function with the 2 arguments. So, let us change this one, and in this case I just put the 2 arguments x and t. So, in this case I am putting the 2 argument, and then I am here I am defining the squares, sum and the squares. So, I am doing the squares first of each function, each argument, and then putting the square and then the sum. So, this is the value I am defining. So, again I have to save. So, this is the saved, the name is same, only the argument, the number of argument has changed. Now, if I want to define this function, so this is the function, it will give the same, that not enough inputs. Now, I will give the inputs here. Now, I will give 2 and 3, 2 and 3. So, this is the 2 arguments I have given. So, that gives you the value 13. What will happen if I give the 1 argument only? So, it is show you that not enough input arguments, then we have to find, because it gives the header, or it is give the body, that whatever the function we are calling, inside that function this is the defined function. So, in this, from here I can see that okay, I have to give the 2 argument. So, I will pass the 2 argument and it gives you the answer. So, in this way we can define the function script file, and this is the function, we generally call it the function script function file, or this is the same as we used to do in the subroutines whenever we used to do programming in the Fortran or maybe C. So, then in that case we have to define the subroutine. So, this is the subroutine basically we are defining. So, in this case I can call this function from any script file, and that file gives me. So, let us define clear all CLC. So, I want to see that. So, okay, this file directory contains the function whatever we have script file defined, that is first.m, and this is the function we have defined. So, let us go to the script file. So, where is the my script file? Open. So, open means this is the first file I am defining. Yeah. So, this is the file. So, in this case suppose I want to use the function. So, what I do, this is my t is there and x sin t is there. So, I just make it maybe t is there, and then and then I will pass this one. So, now I call t is there and I call x is equal to maybe t, let us multiply by t itself. Okay. So, I get this x. Now, I call the function and I will take another value, that is z value I am defining, and in this case I will find SQU. I just call that function SQU and pass this t and x. Okay. And then I define the figure 1. So, in the figure 1 I will plot this t and maybe z. I will plot this one. All other just I delete. Okay. And then I will run this one. So, that is the plot. So, see in this case we have just defined the Lin space, and t is, I am defining a t from 0 to 2 pi, maybe I can define from 0 to 1 in this case, okay. And this is the plot. So, I am defining the t from 0 to 1, then I have defined the x, that is t square, and then I call the function from here. So, z is equal to this one. So, what is the z here? So, it gives you the, so what is the z? So, z is this one. So, z is t square plus x square, because if you see the t is this one, because I have a function now and x is this one. So, let us try this one. So, I just take a t 10th value square of that plus x 10th value and then square of that. So, that is the value, and I just want to check that what is the 10th value of z. So, that is the value of z, this and this. Okay. So, instead of doing the same things here, I am calling my function from this script file, and that function is used here to find the square of t square plus x square, and then I am using this function to find the plot in this script file. So, the same MATLAB functions can be used in the different script files, and using these script files, using these functions, I can use my codings to do the further coding for whatever the scientific computing I need to do, and based on this one I can always use the same function in various script files. So, that is all we can do with the function file and the script file, and now I think we have enough knowledge about the basics of MATLAB. So, now we can start our scientific computing course, and then we can discuss various methods to whatever is given in the syllabus of the scientific computing, and then we can make the MATLAB code, and use the MATLAB code we can verify whatever we are doing in the scientific computing. For example, suppose we from the next lecture we are going to start with that how the errors comes to the computation, and then we will go on, we will define that how we can define the roots, maybe roots of a nonlinear equation, and in that case we will discuss the various method like a bisection method or the Newton-Raphson secant method. So, we will make the code for those methods in the MATLAB, and then we will verify there itself. So, that is all about the basics of MATLAB. So, I hope this is enough for you to start with the scientific computing. So, we will go, from the next lecture we are going to start with the scientific computing. So, thanks for viewing. Thanks very much.